DevOps and CI-CD Part 25. This episode has 7 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain Jenkins architecture. Here's a strong way to approach it. Jenkins architecture. Jenkins is an open-source automation server used to automate build, test, and deployment processes in CI or CD pipelines. Its architecture follows a controller agent, master agent model. Jenkins architecture diagram. Developers v GitHub or GitLab v Jenkins controller, master node, plus, scheduler, job management, plugins, UI and configuration, plus or v Jenkins agent 1 Jenkins agent 2, Linux build, Windows build v build or test app 1. Jenkins controller, master. The controller is the central component responsible for managing Jenkins configuration, scheduling jobs, managing agents, installing plugins, monitoring pipeline execution, providing the Jenkins web UI responsibilities, receives build triggers, assigns jobs to agents, maintains build history, stores pipeline definitions, coordinates distributed builds. 2. Jenkins agents, workers. Agents are machines that execute the actual jobs assigned by the controller. They can be physical servers, virtual machines, Kubernetes pods, Docker containers. Responsibilities: build code, run tests, execute deployment scripts, generate artifacts. Example: Agent 1 Java build, Agent 2 Python build, Agent 3 Docker build. 3. Communication between controller and agents. Jenkins controller communicates with agents through SSH/JNLP, Java Network Launch Protocol, WebSocket Common Setup, Controller, SSH. Agent 4. Jenkins pipeline. A pipeline is a series of automated stages. Example: checkout code, build unit test, security scan, Docker build, push image, deploy. Pipeline code is stored in a file called Jenkins file. 5. Jenkins plugins. Jenkins is highly extensible through plugins. Popular plugins: Git plugin, Docker plugin, Kubernetes plugin, Sonar Cube Scanner for Jenkins, Slack notification plugin, real-world CI or CD flow, developer pushes code, GitHub webhook. Jenkins controller, assign job to agent, build application, run tests, build Docker image, push to registry, deploy to Kubernetes. Why use multiple agents? Benefits: parallel execution, faster builds, better resource utilization, platform-specific builds. Example: Linux agent backend build, Windows agent NET build, Mac agent, iOS build. Interview answer: 2 minutes. Jenkins follows a controller agent architecture. The Jenkins controller manages job scheduling, pipeline execution, plugins, user authentication, and the web interface. Agents are worker nodes that execute the actual build, test, and deployment tasks. When a developer commits code, Jenkins receives a trigger, schedules the job, and assigns it to an available agent. The agent performs the required tasks and reports the results back to the controller. This distributed architecture enables scalability, parallel execution, and efficient resource utilization. In enterprise environments, Jenkins is often integrated with GitHub, Docker, Kubernetes, Sonar Cube, and artifact repositories to build complete CI or CD pipelines. Nice. Let's continue. Question 2. What is Jenkins master agent? Here's a strong way to approach it. What is Jenkins master agent architecture? Jenkins master agent, controller agent architecture is a distributed build architecture where master, controller, manages and schedules jobs, agents, workers or slaves, execute the actual build, test, and deployment tasks. This architecture helps Jenkins scale by distributing workloads across multiple machines. Architecture: developer v GitHub or GitLab v Jenkins master, controller or scheduler. .vvv. The exact commands and code are in the written question bank. Great. Moving on. Question 3. Explain Jenkins pipelines. Here's a strong way to approach it. Jenkins pipelines. A Jenkins pipeline is a collection of automated steps that define the build, test, deploy process of an application. Instead of manually performing tasks, Jenkins executes them automatically in a defined sequence. Why use pipelines? Automate software delivery, reduce manual errors, ensure consistent deployments, faster feedback and releases. Pipeline as code using a Jenkins file. Typical pipeline flow: code commit, checkout code, build application, run unit tests, code quality scan, security scan, build Docker image, push image to registry, deploy to Kubernetes. Pipeline as code. Jenkins pipelines are usually stored in a file called Jenkins file inside the application's Git repository. This allows Version control code reviews reusability auditability types of Jenkins pipelines 1. Declarative pipeline simpler and recommended. Example, pipeline. The exact commands and code are in the written question bank. Alright, next question. Question 4. What is Jenkins file? Here's a strong way to approach it. What is a Jenkins file? A Jenkins file is a text file that contains the definition of a Jenkins pipeline written in Groovy-based syntax. It allows you to define your CI or CD pipeline as code and store it in the same Git repository as your application. This concept is called pipeline as code. Why use a Jenkins file? Version controlled with application code, easy to review through pull requests, reusable and maintainable, consistent pipeline across environments, eliminates manual Jenkins job configuration location. The Jenkins file is typically stored in the root directory of the project or src or pom.xml docker file. Jenkins file basic Jenkins file example pipeline. The exact commands and code are in the written question bank. Let's keep going. Question 5. Explain scripted pipeline. Here's a strong way to approach it. What is a scripted pipeline? A scripted pipeline is a Jenkins pipeline written using Groovy scripting syntax that provides maximum flexibility and control over the CI or CD workflow. It is the original Jenkins pipeline format and is useful for complex logic, loops, conditions, and custom workflows. Basic structure node. The exact commands and code are in the written question bank. On to the next one. Question 6. What is declarative pipeline? Here's a strong way to approach it. What is a declarative pipeline? A declarative pipeline is a Jenkins pipeline written using a structured, predefined syntax, DSL, that makes CI or CD pipelines easier to write, read, and maintain. It is the recommended approach for creating Jenkins pipelines because it is simpler and less error-prone than scripted pipelines. Basic structure pipeline. The exact commands and code are in the written question bank. Good. Here's another one. Question 7. Explain GitHub Actions. Here's a strong way to approach it. GitHub Actions is a GitHub native CI or CD platform that runs workflows from YAML files stored in a repository. It is commonly used to build, test, scan, package, and deploy applications whenever code is pushed, a pull request is opened, or a manual trigger is used. Detailed interview explanation. GitHub Actions belongs to the software delivery life cycle. In interviews, explain how it helps teams move from source code to production safely. The key themes are automation, repeatability, traceability, testing, security validation, deployment control, and rollback. Production example. A production pipeline may start when a pull request is opened. CI runs unit tests, integration tests, static analysis, dependency scanning, and image scanning. After approval, the pipeline builds an immutable artifact, pushes it to an artifact registry, and deploys it using Kubernetes, Helm, Argo CD, Flux, or another deployment system. For production releases, teams add approval gates, canary or blue-green rollout, slow checks, and rollback automation. Best practices to mention. Keep pipeline definitions in Git and review them like application code. Promote the same immutable artifact across environments. Use secret managers and short-lived credentials instead of hard-coded secrets. Add automated checks for tests, security, policy, and deployment health. Measure delivery using DORA metrics, deployment frequency, lead time, change failure rate, and MTTR. Common interview follow-ups. You may be asked how to handle flaky tests, slow pipelines, failed deployments, manual approvals, artifact promotion, branch strategy, GitOps drift, or rollback. A strong answer connects the concept to faster feedback, safer releases, and better auditability. Nice. Let's continue. That wraps up this episode. Nice work practicing, and see you in the next one.